Good morning everyone, I am Bhargavi, 3rd year BSc ATOT student.
Good morning, I am Jivita, 3rd year BSc ATOT student.
Today we are going to give a brief information about the mechanical ventilation settings. Let us know what are ventilator settings. Ventilator settings are considered on a mechanical ventilation that can be set or adjusted in order to determine an amount of support that is delivered to the patient.
Support can be given in the form of ventilation and oxygenation. The basic ventilator settings are ventilator mode, tidal volume, frequency flow rate, fraction of inspired oxygen, inspiratory flow rate, inspiration to expiration ratio, sensitivity, positive and expiratory pressure, and ventilator alarms.
Let us know what is ventilator mode. Essentially, a ventilator mode is a way of describing how the mechanical ventilator assists a patient with inspiration. The characteristics of a particular mode control how the ventilator functions. Common modes of mechanical ventilation include assist or controlled, synchronized intermittent mandatory ventilation, pressure support ventilation, continuous positive airway pressure, volume support, control mode ventilation, airway pressure release ventilator, mandatory minute ventilation, inverse ratio ventilation, and high frequency oscillatory ventilation.
Tidal volume. Tidal volume refers to the volume of air that is inhaled and exhaled from the lungs during normal breathing. If a patient is in volume control mode, the delivered tidal volume can be adjusted by decreasing or increasing the tidal volume settings. If a patient is in pressure control mode, the delivered tidal volume can be adjusted by increasing or decreasing the pressure setting.
Frequency, that is respiratory rate. It can even be referred to as the breathing rate because this setting simply controls the rate which breathing occurs. It is 10 to 20 beats per minute. The frequency setting of the ventilation determines how many breaths are delivered to the patient that is per minute by the machine.
Fraction of inspired oxygen. This refers to the concentration of oxygen that being inhaled by the patient. If a patient with severe hypoxemia, an FiO2 of 100% is required when mechanical ventilation is initiated. If a patient receives FiO2 more than 60% for a prolonged period of time, it increases the chances of oxygen toxicity.
Flow rate. This setting controls how fast a tidal volume is delivered to the patient by the ventilator. The setting can be adjusted depending on the patient's inspiratory demands. That is 60 liters per minute. Most ventilators can deliver up to 120 liters per minute if a patient needs a prolonged expiratory time. If it is set too low, it could result in patient ventilator dysynchrony and increased work of breathing. If the flow rate is set too high, it could result in decreased mean airway pressure.
Inspiratory to expiratory ratio. It refers to a ratio of inspiratory portion compared to expiratory portion by breathing cycle between 1:2 and 1:4. A larger inspiratory to expiratory ratio may be delivered if a patient is in need of a longer expiratory time due to the possibility of air trapping. Adjust the patient's inspiratory to expiratory ratio by making changes to the following settings like flow rate, inspiratory time, expiratory time, tidal volume, and frequency.
Trigger sensitivity. The sensitivity control is what determines how much effort the patient must generate in order to trigger a breath from the machine, that is -1 and -2 cm H2. It will cause the ventilator to initiate auto minus triggerings and increases the total frequency of breaths. The patient could have a difficult time initiating a breath.
Positive and expiratory pressure. Positive and expiratory pressure is essentially an amount of positive pressure which is delivered during the expiratory phase during normal breathing cycle. It helps to prevent the closure of alveoli in the lungs, which allows an increased amount of time for oxygen exchange to occur. Most common indication for positive and expiratory pressure in a refractory hypoxemia and those who have not responded well to a high FiO2 setting. Their PaO2 and SpO2 levels just aren't quite where we need them to be. In this case, FiO2 is provided up to 60%.
Let us know what is ventilator alarms. Ventilator alarm is a safety mechanism on a machine that uses a set parameters to provide alerts whenever there is a potential problem related to the patient negative ventilator interaction. Common alarms include high pressure, low expired volume, high frequency, apnea, high positive and expiratory pressure, and low positive and expiratory pressure.
In initial ventilator settings, once it has been determined that mechanical ventilation is indicated for a patient who needs help with oxygenation or ventilation, then you must know how to properly input the initial ventilator setting. And each mechanical ventilation machine is different.
Let's come to modes. Any operational mode will work when setting up the initial ventilator setting. The rates are 12 to 20 breaths per minute, 12 to 14 obstruction or asthma, 18 to 20 ARDS or pneumonia. Decision based on the clinical conditions and ABG. You can select assist or controlled mode if the patient needs full mechanical ventilatory support. You can select synchronized intermittent mandatory ventilation if they only need partial support.
Coming to tidal volume setting. The initial tidal volume setting should be 5 to 10 ml per kg for a patient with ideal body weight. If a patient weight is about 70 kg, then the patient initial tidal volume settings should be between 350 to 700 ml.
Let us know about frequency. The initial FiO2 setting should be 30 to 60%. Unless the patient was previously receiving a higher percentage of O2 before intubation. You could simply use that previous FiO2. An FiO2 up to 100% as an initial setting is appropriate for patients with severe oxygenation issues.
Flow rate. The initial flow setting should be 40 to 60 liters per minute.
Inspiratory to expiratory ratio. The initial inspiratory to expiratory ratio setting should be between 1:2 to 1:4.
Sensitivity. The initial sensitivity setting should be between -1 to -2 cm of H2O.
Coming to